Everyone. Thanks for joining this session. I'm very excited to host Srihari. He's currently analytics team lead at Claim Genius. One thing I really found unique about his, like, he came from an architecture background. He graduated in 2017 and did his PGP in big data analytics, and uh, his Medium articles are quite amazing. So I thought, why not we can organize this session and share his journey and insights about his work with everyone. So, and he was quite supportive about it, and we are here now. So thanks a lot, Shriyari, for your time to do this.
Thank you. Thanks, Mayur, for having me. It's great, and I'm glad to be part of this great series that we're going to put up. So yeah, I'm excited.
The structure is Srihari will be presenting his work and which is published on Medium articles. So first we'll go through those work, and if you have Q&A, you can type it in the chat and I'll ask those questions.
Cool. All right, let's get started. So I'll be presenting some of my work in terms of Medium articles that I've put up, and then so I've been working on these exploring different technologies, be it in big data analytics or data science and AI, especially since the inception of these the cutting edge technologies that have been coming into all these industries. Architecture is like it seems like it. There are a lot of things that are happening globally. I thought, like, why not explore different technologies and um, so basically, when I thought of pursuing this data science, it was not very clear for me like how data can be used. We all speak about a lot of these BIM softwares and a lot of data putting coming in into the system. Um, and also, it was a very narrow channel of only focusing on, let us say, environmental design, where to deal with all these environmental variables to kind of design certain buildings. That was basically it when I just started it. But actually, data science can also be used in decision making, which is like a very major part of any creative project, like especially in architecture and urban sciences, urban design. You have to be very specific about, and you need to back that with the data and facts. So the way I started this is basically I will just go through a simple article that I started initially. So this is a small attempt to understand basically the effect of traffic scenario. Basically, Hyderabad Metro. Basically this was a project that was initiated, and it took quite some time to get realized and operational. So basically, I just tried to analyze. What is the effect of this metro work on the city? Like, did it actually help the city in terms of the lessening the traffic burden, or during the construction period was there any? So the way I did this basically is I just collected some data of Uber movement. This was a data set that kind of they open sourced Uber data open source, like in major cities like Hyderabad, Bangalore. At the time when I started this back in 2018-19. So I just wanted to see if there's any correlation in terms of the overall traffic. I just took this small data set and tried to explore if that can be correlated to any of the global city level scenarios. So uh, basically, Uber movement, they have basically open source some of these data, which they've been tracking it from their Uber rides, uh, based on, like, the total traffic that happens, and it's a consolidated data set of a certain time frame. And basically, I started exploring this data sets. So I just took a simple scenario of two different destinations, like the inception starting of a metro line in a particular city, and then the ending part, which is here. This is Hyderabad scenario. Uh, Basically, it's a 35-kilometer long stretch, and I have taken this data of Uber movement data sets, where starting from so basically this got operational in December 2017, right? Uh, I've taken different time frames just to analyze what was the scenario before this, during this, and after this, just to get a sense of is there any difference, so that I could correlate that in terms of the traffic. So what I've taken is basically the quarter four data range of 2016, 17, and 18. So 17 is where this all things started, and 2016 is pre-metro, and 2018 is post-metro. So in order to understand the difference, you need to have that range, so that only like analyzing 2017 data doesn't make any sense, because we need to understand what was the scenario before and after to clearly see the difference. So uh, the way I just did it is like I just downloaded this data 2016 Q4, 17, and 18. And it's a simple exercise of just manipulating the data within, using Python. And basically it had different, basically what it, kind of denoted is basically the time taken for a trip to, and from a starting point to an end point, based on the different watts that has been divided inside this. What it essentially gives us is basically the average time that is taken for a cab, let us say a trip to complete from destination A to B within the city. It's not a single data wherein like you're talking about multiple trips together, and if everything is consolidated over an average, average would actually give us a complete understanding of the total traffic scenario. That is the reason why they've even released this, in order to help these urban designers and city planners to take and leverage this data and use it in their designing part. So so this is what I did. I just took the data, travel time data for all the 3 years in the Q4, and then basically just did some manipulation. And I what I tried to find out is basically the so this final this infographic kind of sums it of everything. Uh, so if you look at this, the red line talks about 2016, which was pre-metro. 2017 is during the metro, and 2018 is after that. So if you look at this basic time plot, and this the y-axis talks about the time in minutes. Basically, I've plotted the time taken in terms of trips, average trips, versus the total hour of the day. Basically, during of course like the office hours, and especially during the evening times when the traffic is in the peak, that's when you expect the graph to be up, right? And this talks about, if you look at these, there's a slight difference that you can make out, especially after post metro, the travel time kind of decreased. So this graph basically just simple data analysis, which will actually help us understand the traffic situation, and try to give some insights in terms of how the data could be leveraged in understanding all this stuff. So this is simply a very small exercise that I did. I just tried to put this up, and basically this kind of helped me to understand a lot of insights from this.
I see. I was just thinking, like, because even when I was leaving, there is metro construction in Mumbai, and that increased the traffic. So I'm just curious. So looked like even like during the metro construction, the travel time decreased, and I was expecting maybe because of the construction there would be more traffic. So it might be possible that the people might have routed on another route, because on the Google map you showed there are like two ways to reach that destination. So maybe on the other destination there would be increment in traffic or duration time.
Yes, right. So that's the reason why I just took the average time, just to in order to account for all those things. Basically, there's a lot of possibilities, right? Like if the major, so this actually the use case that I've taken, this Elvinagar to Miyapur. This is the main road, which is like dissecting through the city. It's very like it's a highway road, say, basically, wherein like all of these internal link roads would actually again converge here in order to kind of make that complete line as a transit line. So there's a possibility, but if you actually take a look at the average, time commute based on all these different cases of Uber Transit, what it ultimately gives us is like an average time, which is actually representing the reality as close as possible. And yeah, there's a lot of other things as well. Like this is a very simple naive experiment that I did, but actually using this technology and basically trying to you look at the data objectively will actually help us kind of like address all these challenges that we have in terms of the unpredictability, and it's basically the nature of the city wherein you cannot predict it. It's not a simple A to B travel, so it's one kind of a problem, right? It's a lot of other attributes coming into place and all that. But yeah, I agree that there could be a lot of things that could be done, which kind of the basic model can be built in order to understand like what is the actual effect of that metro. Yeah,
Yeah, and I think it's a super interesting work because you, based on this data, you could justify that the city, the decision they made, this is how much exactly the time difference it was converted. It's not subjective that okay, make a matter, hopefully it will decrease the commute time. It, you can quantify. And I'm just thinking like, if like to take it to next level, suppose I want to propose a new metro in location B. Are you thinking that we can have like similar regression or stats data on many metros, and then we can do prediction that okay, if we build this in future, this is most probably the reduction.
yeah, yeah. It's quite possible, right? Like we knowing this, like as a model which kind of worked for a certain city or which didn't work for a certain city, we could kind of consider those attributes, and yes, the regression can definitely be built up. I don't see any challenge in that. But only thing is like we need to make it more robust so that we do not add unnecessary noise. Basically, again, as an urban designer, it's important to understand that each city conditions are different. You cannot generalize it, but yeah, considering different factors, at least we could get an initial estimate of how things might be and basic it's for decision making. So definitely all that regressions would help us to take that decision. So that is what data driven decisions is actually play an important role while having these